Hi. So one thing that we need to specifically mention is something called a geostationary satellite. It's a special type of satellite that is used a lot in communications around the Earth, and the name geostationary means basically that it stays above the same point on the Earth at all times. Now, there's a specific learning outcome about this. If we'll just look at this now. Sorry. Yeah, okay. So here, I know that geostationary satellites have a period of 24 hours in an orbit at an altitude of 36,000 kilometers above the equator on the Earth's surface. Now, I've mentioned geostationary satellites a number of times in the previous video, and there's a specific learning outcome there, and that's what it says that you need to know. So we have a period of 24 hours in an altitude of 36,000 kilometers above the equator. There's three things there that are really, really crucial that you know and understand. So I'm going to try to explain how a geostationary satellite works. It's going to be kind of challenging to do. It's challenging at the best of times, but trying to do it on a sheet of paper could turn out to be quite interesting. So here we go. So with a geostationary satellite, we will have the Earth. So if we're looking straight down on the Earth, we're looking top down, and the Earth rotates. And so the Earth is spinning around on its axis. Looking top down, we're going to see the Earth moving around. Now if this is us here, let's just see there, then it takes 24 hours for us to move all the way around in space, I guess, and it takes everything 24 hours to move around one time. Okay. Now, from a previous lesson, we knew that from Kepler's third law, that the period of a satellite is related to the altitude of it. And so if you have a satellite in a low orbit, then it would take maybe, I don't know, 5 hours. And if you had a satellite in a higher orbit, this, we could say that this satellite would probably have a period of, let's say, I don't know, 30 hours. So you can pick the altitude exactly to give a period that coincides with the time that it takes for the Earth to revolve once. And so this is the bit in the geostationary satellite where it has a period of 24 hours and an altitude of 36,000 kilometers. Now these are just numbers that you should remember. In a lot of space, we're going to say you're going to have a basic understanding of this, or you're going to have an awareness of something. This is a specific fact that you're going to be asked to remember, that I'm going to ask you to remember. A period of 24 hours and an altitude of 36,000 kilometers. They are directly linked. From this Kepler's law, Kepler's third law, it must have the exact altitude, and this is talking about radius here, but from the center of the object, but this 36,000 kilometers is actually the height above the surface of the Earth. And so we're ignoring the 6.4 million meters, or the 64,000 kilometers radius of the Earth itself. No, the 6.4 thousand 6,400 kilometers. Yeah, so 6,400 kilometers radius of the Earth, and then your geostationary satellite is another 36,000 kilometers on top of that. So you've got the Earth here, and you'll have your satellite, which is placed at this exact point. Now, if you had, let's see if I can, I don't even think I have a ball here, even to show you. My balls are now all in the school, so I'm just going to have to do with circles. If you have the Earth that is like this, and it's rotating around like this, and you have a satellite that's orbiting like that, and the Earth is rotating like this, and so as you're rotating like this, and the Earth is, this is why I'm saying it's difficult for me to explain to you on a paper and a video, and it's much easier in person. But so if it's rotating around like this, and your satellite is orbiting like that, then as the Earth is turning, let's see if I'm going to have, yeah. So there we go, we want it to stay above that point. Now if the Earth is rotating like that, but we're having our satellite that's orbiting like that, then that's not going to work, because it's not going to be above the same point. And the idea of a geostationary satellite is it stays above the same point on the Earth's surface. So that's a polar orbit, and we could have it orbiting directly over Fortrose, say. So this is Fortrose here, and if it was going around in some sort of way like that, we're there, as it rotates, we're going to pass directly overhead at some point when we're here, but then as it rotates away, it's going to have to move around a complete circumference of the sphere. We can't have it moving, because Fortrose is like up here. We can't have it moving around in an orbit like that, just above that surface, because it needs to travel around a full circumference of the sphere, and so it's got to travel through two opposite points of the Earth. The only way to get that is if it's directly out from the equator, and that the satellite is moving as the Earth is moving. And so if the satellite is moving here and the Earth is moving at the same rate, then a geostationary satellite will always be above the same point on the equator. Now, if we go to a different view of the Earth, and so let's just say we've got north-south, and we're going to say that Fortrose is somewhere here. This is still okay, because if our equator is around here, and we have our geostationary satellite somewhere here, we will still have a direct line of sight to that satellite. Okay, and as the Earth is rotating, the satellite is also rotating at the same rate, and so it's always going to be above this direct point on the atmosphere. We could have one, if we were projecting straight out of the page, we could have one that was here, and as that's moving around, the Earth is moving around, and again it's going to be in the same point. I hope you sort of get the idea of this. Now, you may know, you may have seen in a house, so your house it could even be, but you don't have to go far to walk by a house and see a satellite dish. Now, satellite dishes, if you walk by all the satellite dishes, you may never have thought of this before, but you walk by and you look at satellite dish, and the satellite dish will have this arm that comes out and this curved reflector bit. It'll have an arm that comes out, and essentially what you have is it will pick up the radio waves or the microwaves from a satellite, hence why it's called a satellite dish. But you may never have wondered why it's actually pointing on the side of the house. Well, you think, well, if it's a satellite, surely it should just be facing up into space. But what it's actually doing is, if your house is like this in Fortrose, it's pointing around about at 17 degrees. So it's a very, very low angle. It's pointing up in the sky because it's trying to actually point to a satellite that's on the equator and that's sort of down over here. Okay, it doesn't explain it particularly well, but all of the satellite dishes are all pointing towards a specific geostationary satellite that is above the equator. And so if it was pointing straight up, it would just well, it would go up that way, but it doesn't need to go up that way, it just needs to go down that way. So they'll all be sort of aligned at a similar angle to get to a satellite that's on the equator. Now, the advantages of having a geostationary satellite, well, if you're watching your favourite show on Sky TV or whatever, and if you're having your satellite and it's in a polar orbit satellite, if this is you here, let's see here, if you're in a polar orbiting satellite, it's going to be fine when it's coming from the sort of South Pole up to around here. You've still got a line of sight of the satellite, that's fine. Well, for a start, your satellite is moving, and so you would have to have a dynamic satellite dish. You would have to have a satellite dish which tracked the radio waves. The radio waves will only travel in straight lines, and if you've got this satellite that's in a polar orbit, then you'd actually have to have a satellite dish that would move to track it. But even worse, as soon as it goes around over the North Pole and then around here, you're going to lose line of sight of the satellite and you're going to have no communication. And so you would only be able to watch TV for, I don't know, I'm guessing 12 hours or something, while it was actually in line of sight, which is pretty useless for a communication system. Well, yeah, you can watch TV, but only for 12 hours. And so we need to have this geostationary satellite stays above the same point on the Earth's surface all the time, and so it's a fixed position for the satellite dish to be in, and it will always be in that position 24 hours a day. And that is geostationary satellites. As I say, the three things, if you remember nothing else, then you should know that a geostationary satellite has a fixed position above the Earth's surface. Let's just write that down, fixed. Has a fixed position, has a period of 24 hours and an altitude of 36,000 kilometers, and must be, in order to achieve this, it must be above the equator. And that's a geostationary satellite. You will see there's a page in the course notes about this. Geostationary satellites, they've been placed in a particular orbit, and it will go through all of these. It will remain in a stationary orbit above the same point on the Earth's surface. So that's geostationary satellites, and that will just lead on to the next part of the course, which will be space travel. Alright, thanks for watching. Bye-bye.